Welcome back, welcome back, welcome back. I'm Miss Lisa. This is my YouTube channel for everything I want to talk about science and math. And today we are in physical science class doing part 5 of the bond notes. We've had a lot of interruptions, but we've got there. And I also would stop it because we did activities. We ate Cheerios, we ate pretzels and marshmallows. Remember, that's why you love me and Miss Olivier. We give you snacks. Yes, snacks are good right before lunch, especially. All right, so if you remember, we have been doing dot structures. Remember the Cheerios where we did dot structures? Okay, so when we did that, one of the things we did when we passed them around the room, oops, wrong one, is we did nitrogen. So let's review the dot structure for nitrogen. What do I do? Where do I start to know how to make the dot structure for nitrogen? Where do I start? The periodic table, yes. So I find nitrogen and I count how many squares over it is. 1, 2, 3, 4, 5. Everybody understand how I did that? Counted 5 squares over. Now I put dots around, just starting on one side, doing one at a time. 1, 2, 3, 4, 5. They all get one dot before you double up. That's something called Hund's rule in chemistry, and it's that the electrons each get their own orbital, their own little place to hang out in the atom before they have to share. Just like you guys, when y'all were little, everybody got a room, and then along came brother or sister, and then you started having to share a room, right? Most people don't start off right off the bat sharing. They get to have their own room until their little brother or sister comes along. Were you the little brother or sister who came along and made your siblings share, or were you the oldest who got to resent the brother or sister moving into your room? I was the little sister who came and shared my big sister's room, and I thought it was great. And she hated it. She hated sharing a room with me. She would put down tape, basket tape on the floor, and say that I wasn't allowed in her half of the room. Do y'all have these problems? But my half of the room had the door. So I told her if that's true, she can't use the door. She was going to have to go in and out the window. She said no. She was very bossy about that. So I'm sure y'all get along great with your brothers and sisters. None of the silly fighting we did. Okay, so notice how there's one dot on each side of the nitrogen on the bottom. Do you see that? Where there is one dot is where nitrogen makes a chemical bond. It's where it's going to bond to something else. Where it has 2 dots together, it does not bond. It's already got a pair, and bonds have to be a pair. So that is not where a bond happens. So that is called a lone pair. It's an unshared pair. It's where there's not a bond. Now, so what this does, ammonia will bond with hydrogens. The nitrogen will bond with hydrogens. And each hydrogen will put in its dot. And this is the structure of ammonia. Do y'all know what ammonia is? It's where you clean with it sometimes. It used to be more popular. Now people like El Fabuloso and some of those things. But people used to clean with Pine Sol. There was and ammonia, stuff like that. So, did I tell y'all where ammonia got its name? Ammonia is an ancient thing. It's been around a long time. And where it got its name was actually ancient Egypt. In ancient Egypt, they worshipped the gods of Egypt, like Isis. Remember those Egyptian gods? Well, there was one called Amun-Ra. Have y'all heard of Amun-Ra? How they worshipped him is they would do human sacrifice to him. They'd burn people up. It was an outdoor temple, and they would human sacrifice to him, and it would make ashes. The human remains would then be ashes, and then it would rain, and rain mixed with ashes makes ammonia. Ammonia has a very distinctive smell. They thought that smell was Amun-Ra coming to collect the souls of his sacrificed people. Isn't that something? So when you see ammonia, know it's named after Amun-Ra, the Egyptian god from human sacrifice. I am glad that's not a popular religion here, and that I don't have to worry about getting sacrificed to Amun-Ra. Don't you agree that it's pretty good that we're not worshiping Ammon Ra? So that's ammonia. That's the chemical. Darrell, I want to see your eyes. Zach, I want to see your eyes. When I was a little kid, there was this show called Romper Room, and the lady would say, as she looked at the TV, I see Susan, and I see Michael, and I see Beth, real common kind of names, so that the kids who were watching the TV would go, oh, she's talking to me. Do you remember Romper Room? Yes, with the mirror, her magic mirror. I always wanted her to say my name. I don't think she did. But one time my friend, she said my friend's name on her birthday. But anyway, I always feel that when I go. I want to see Zach's eyes, and I want to see, like, I feel like I'm the Romper Room lady. But anyway, so Romper Room was way before your time, but I remember Romper Room. Okay, it was one of those PBS shows. So so we have done this a little bit in our lab yesterday. We talked about how there are different kinds of structures that you can draw. So what we're going to do is we're going to look at methane, CH4, and its Lewis structure. You put carbon in the middle. You do its 4 dots for its 4 bonds. Remember, carbon's 4 over, it gets 4 dots. And then around it, you put 4 hydrogens. And each hydrogen contributes its 1 electron, and carbon contributes its 4, and it makes 4 bonds. So that is the Lewis structure of methane. This is methane. Now methane is its chemical name. We're going to talk more about that. But where do you find methane? Sometimes it's found in this room. Well, it's always found in this room, but sometimes more than others. Well, what's methane? Anybody know? What's methane? My 4th period, I have a student who has a lot of problems with methane. Gas? Yes, it's gas. When you pass gas, when you poop, that's what you're pooting, methane. So now look what good science we're learning. How to do the structural formula, the Lewis structure for poops. It's also the gas that's in our gas jets when we light the gas. Now those smell different, don't they? Turns out real methane has no smell at all. When you pass gas, the stink you're smelling is the bacteria that is in your gut. You have to have bacteria in your gut to digest your food. Do you know if you don't, if you take an antibiotic that kills all the bacteria in your gut, it can cause you to die? I knew this mom who her husband, they had gone to another country. He had gotten an infection that then was treated where it killed all the bacteria in his guts, and he almost died. And what they do for you if this happens is they do like a blood donation to you, but they'll do a poop donation. It's just like how you donate blood, you can donate poop. They put it in a blender with saline and shoot it up you to try to get your bacteria growing again inside of you. And that's what he had to have done, because he almost died because all that bacteria got killed by the antibiotics they gave him. That's kind of weird, isn't it? I hope that never happens to me. I don't want to have anybody's blood or poop. No, thank you. Hope that doesn't happen. But still good to be a blood donor, right? Okay, so the smell you smell when someone passes gas is bacteria. The smell when you turn on the gas, when we're doing lab, they add that to it, so that if there's a gas leak, you'll smell it and turn it off because it's dangerous. If you have a gas leak and then there's a spark, it can cause an explosion. We're doing notes, so get those out. A few years ago, maybe 15 years ago, maybe it was around 2005, I'm thinking, in Austell, Georgia, there was a house that had a gas leak, and the mom and kids had left. The dad got home from work, walked in, there was a spark, the house exploded, it killed him. I saw the house afterwards. It was right next to Orange Hill Baptist Church in Austell. It looked like there was nothing left. There were little pieces of wood as big as a matchstick, and that is all that was left. So we always want to be really careful with methane, that it can burn, it can explode. So the next question I always get is what? can you, oh, surely that y'all are not so far from middle school that you haven't thought of this. Yes. Can you burn poots? Yes, you can. You can light poots. Is it safe? No. Should you do it? No. So if someone ever dares you to do it, don't think, oh, that won't work. It does work, and you can get very burnt in a very sensitive part of your anatomy. So don't light poots. All right, so that's our little methane talk. Zach, did you hear me? Don't light poots. Okay, there we go. So this is the Lewis structure. You also can write the molecular formula, and that's where you just write the elements so together. 1 carbon, 4 hydrogens, you write it as a subscript. The last one is called the structural formula. It's the same as the Lewis structure, but wherever you have 2 dots, instead you put 1 line. That's an H. I don't write slow, it makes extra lines. So that's the structural formula. In our lab today, we're going to be doing that, but we're also going to do another one. I'm going to draw this here. All right, which is the model. When you draw the model, what you're going to do is you're going to draw it ball and stick. So just so you know what that is, there's a model of it. Ta-da. My model didn't write too good. Left off the L. It's like model. Okay. Now, electrons can share more than, atoms can share more than 1 pair of electrons. If they share 1 pair, what do you think that's called? What kind of bond? Single, double, or triple? Single. You're brilliant. Yes. It's single. What do you think 2 pairs are called? Double. What do you think 3 is called? Triple, yes. So they can share more than 1, and we're going to practice that in our lab that we're about to do. All right, Miss Olivier, we are ready for a roll. Try to go click, 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 like, 10 times all over it. Let's see if it'll go.
Up in the back.
What? Oh, yes, sir.
What is 1 pair and 2 pairs called?
1 pair is called single. 2 pairs is a double. 3 pairs is a triple bond. You're welcome. This is the easiest grade you get in here. All you have to do is write down what's on the board. So make sure you do it.
It's not cooperating.
Not cooperating. All mine, it did good for a while. I guess you'll have to close it out. Just exit out and reopen it. And we'll know that we're at the end of the double, triple bonds.
Okay, you want me to reopen it?
Yeah, go there. It should be the top thing right there. Now I'll roll.
How do you get that draw up there?
You click it here. Oh, how do you get if it's not on yours? You right click anywhere in the gray and you go to properties and it's there. You can add it there. It's the toolbar property or something like that.
Oh, yeah, got it.
Okay, so now covalent. We talked about naming ionic bonds, like so you say the cation, you say the metal, sodium. You say the non-metal, but you change the ending to "ide," so it's sodium chloride. Everybody remember that from yesterday? Covalent is different when they share electrons. They use prefixes to tell how many. Prefixes tell how many. What number do you think mono stands for? 1. What do you think di is?
2.
2. What do you think tri is?
3.
Like a tricycle? What about tetra?
4.
4, like the game Tetris. Do y'all like the game Tetris? I find it too high pressure. I have to scream because those little things are coming too fast. And I go, trying to turn them. It's too high pressure. How about penta? 5, because pentagram, pentagon, right? What about hex? What do you think hex is? 6. A hexagon, remember that from geometry class? Now this is the one nobody knows. What do you think hept is? 7. Have y'all heard of hept before? No, I don't know why. Nobody likes hept. Maybe it's because it's hard to draw. What about oct? 8. Octopus. Have y'all heard the Flippy the Fish Head octopus song? How many legs do an octopus got? 8 legs. 8 legs. 7 legs? No, 8 legs. 9 legs? No, 8 legs. That's how many legs an octopus got. It's a little counting song. You can tell it's not teaching grammar because that's incorrect. But it is teaching you that oct is 8. An octopus has 8 legs. Okay, what do you think non is? 9. Starts with an N. And dec? 10. So here's my little pet peeve. Is people will use the word decimate wrong. Dec means 10. So if an army is decimated, what does that mean? Are they completely destroyed? No. 1/10 has died. 90% are ready to fight again another day. I hate hearing the word decimate used wrong. Decimate means only a tenth. If a city is decimated, 1/10 of it was destroyed. 90% of it's just fine. Did y'all know that? No. So you've heard that word decimate? That's what it means. Zach, I'm not seeing your eyeballs again. There you go. As nice as the top of your head is, I like the eyeballs. That's what I want to see. That's how I look to see if you're understanding. All right, so here is an example. What you do is normally, if it is 1, you don't use mono in the first chemical. You only use it in the second chemical. Guadalupe, got that? Okay, so this one, there's 1 carbon, but it's at the beginning, so we don't use mono. We say carbon, because there's just 1, but there are 2 oxygens. What is 2? What's 2? Look at the chart, we just filled it out. Di, and then oxygen is oxide. Have you heard of carbon dioxide? Carbon dioxide, does that make sense to you? I think these might be a little bit easier than the other ones even. I like these. So this one is only 1 carbon, so it's carbon. And now it's the second word, so we do use the prefix. There's only 1 oxygen, so what's this one called? Carbon monoxide. Have y'all heard of that one? Carbon monoxide is produced by incomplete combustion, and it's a odorless, colorless, poisonous gas. You hear about people dying from it all the time. People will, okay, so we don't get snow much in Georgia. The weather show said once every 2 years. So when we get a little snow, a lot of times we don't know how to handle it. So it'll be, the power will go out, and people will be cold and hungry, and they look out on the porch and go, I got a gas grill. What if I pull the gas grill in the house? We can cook up some steaks that are thawing out of the freezer and get warm. Will that work? No, it will kill them. Happens all the time because grills give off carbon monoxide. It's fine when it's outside, but if you breathe it in the house where the carbon monoxide can't escape, you will die. Another thing that will happen is it's in exhaust. So like a few years ago, there was it's always Georgia, we get killed with this stuff. There was a truck that they had the covered back camper, and they were going to Alabama. The kids asked if they could ride in the back of the truck, and the parents were nice and said, sure. Little did the parents know that the exhaust that had the carbon monoxide in it was seeping back into the truck bed. They got to Alabama, all 3 kids were dead from the carbon monoxide. Isn't that horrible? The other things where we kill ourselves on accident is the garage. It'll get cold. We don't know how to handle it. We're in the South. We're not used to cold. And so we think, oh, I'll go heat up my car. So the people will go down to their garage, turn on the car, go finish their coffee, come back down, take a big breath as they're walking to their car, drop dead. Carbon monoxide has filled the garage, and they kill themselves on accident. So y'all are going to be careful with carbon monoxide, right? We're not going to light poots, and we're not going to accidentally kill ourselves with carbon monoxide. See how practical chemistry class is? You learn ways not to die. It's and not to get hurt. It's a very useful class. All right, covalent properties. Covalently bonded atoms have different properties. I don't want to tell you what they are. You're like, that's your job. I'm not going to tell you. What I want is we're going to do a lab and you're going to discover them yourself. They will be on the test, but I want you to come back and list them here after we do the lab. I don't want to give it all away. I want lab to be a wonderful discovery process. Okay, the last thing here is acids. So another kind of chemical that we name in science lab are acids. We work with acids. In our reaction lab, we'll be working with some acids. And acids usually start with hydrogens. They have hydrogens that come off, and that's what makes them acidy. So it's the hydrogen plus the anion, the negative part, plus ick, and then acid. So HCl is hydrochloric acid. Hydrochloric. And then the word acid. So you say hydro for the hydrogen, whatever the anion, you say the root of it, chlor for chlorine. You change the ending to ick, because acids are ick. They burn when they get on you. We really do like acids, though. We like lemon juice and tomato juice. We'll talk more about that later. And then the word acid. Now, there are more rules if something is polyatomic. You are not going to learn it. It says right here in your standard that you do not learn about polyatomic things. And on accident, last year I taught it. And then afterwards I read the standard again and thought, oh no, I wasn't supposed to teach that. So I'm going to be good this time and not teach you extra for the low, low price of free public education. All right. And then also we want to talk about metals. The other kind of bonds are metal bonds. Remember we said those were the hippies who let their children just run around wherever they want to. So metallic bonds, metals share electrons. Remember we talked about they just run around wherever they want to? And that gives metals their properties. It makes them strong. It makes them shiny. It makes them good conductors of heat and electricity. Running out of room. I got it. Heat and electricity. They're also ductile, which means you can make wires out of them. Fancy science word for you can make wires out of it. And they're malleable, which means fancy science word that you can make foil out of it, like tin foil, aluminum foil, gold foil. We learned about that. They're ductile and malleable. So there's the one ring to rule them all.
Wait, what does ductile mean?
And you can make wires out of it. Ductile is you can make it into wires. Metals can be wires. They can be foil. So ductile is wires. And malleable means you can make foil out of it. Like aluminum foil, gold foil, tin foil. Do you have like a grandma that will call aluminum foil tin foil? You ever heard, anybody heard that? They used to make tin foil. I actually have some tin foil, but usually our foil that we buy at the store is aluminum foil. But a long time ago, they would sell at the grocery store tin foil. And you'll hear old people say, get a piece of tin foil and put on that and stick it in the refrigerator. And what they mean is aluminum foil. They're not being careful about their metals. All right, that's the notes. Like, share, subscribe. We're going to do an activity. All right. Ta-da. Good job. Good job. So what do you think? Is this going to be a pretty easy test? All right, so this is how we're going to do this. Everybody listen. Everybody listen. Just a second, I'm going to let you put away your markers. No, you still need them. Hold on to your markers. Gil, Alan, listen, I don't want to describe the directions more than once. Darrell, Zach, I want to see eyeballs, and Zach, no hoodie. Remember, we don't want to be sexist and just get onto the girls for their midriffs. We want boys to follow the dress code too. So take your hat and hoodie all the way off your head. Thank you so much. All right. So for our lab activity, we are not going to get in our lab groups because we don't have enough equipment. What I'm going to do is I'm going to divide you into 6 groups where you are, and those groups are going to each have 1 lab kit. So like for example, my first group will be these first 3 tables. I'm going to put the kit on Amaziah's table, and Gavin and Bailey are going to turn around, and those 3 tables are going to work together. You're going to build these model kits, and you're going to draw them. So what I need you to do is I need you to get out this worksheet we started with yesterday, and I'm going to show you how to use the model kit to do the back. So get out this worksheet. You should have got the front done yesterday. If not, you can finish it up today. I want you to turn it over and do the back. All right. Do it quietly. We've got enough time. We've got to do it. We've got lots of time.
Now what am I looking for, y'all?
Okay.
I pulled up the
You're looking for
customized.
Methane properties. Methane properties. No, I think it was for drawing this. I think they're already there. No.
Draw a table.
You might be in the wrong thing. Okay, okay, go up here, right click. Oh, somehow you can customize the ribbon.
I know, I'll figure it out.
And when you find that, then you should be able to click draw, and it'll be there. All right, everybody got this out and got on the back side that says chemistry structures of molecules? Yes, okay. So let's do the first one together. So the first one is Cl2, and this is what I want. First, I want you to do the dot structure. So do this in pencil because you might have to erase. I've got 2 chlorines. I do the dot structure of each one, 1, 2, 3, 4. So there's one of them. Then I do the dot structure of the other one, and I show that they are sharing a bond. Okay, so that's what I want for dot structure for chlorine. Does that make sense to you? We're doing what we did with our Cheerios, but we're making it into a molecule, and we're drawing it right here where it says dot structure for Cl2. So this is Cl2. Next, it asks for the bond structure. What you do is where this is sharing, you draw a line. So you do Cl line Cl. So this one is your bond structure. You don't have to worry about the dots that aren't part of the bond, that aren't being shared, and you draw it like this. Now this is the last tricky part. For the last tricky part, you're going to use your model kit, the 6 or 5 of you together in your 3 tables, and you're going to build the model. So I look on my kit, and I see that chlorine is green. So I find the green ball, I get a stick to represent the bond, and I stick it in between it. I get the other one, and this is my model of chlorine. Can you see that? Everybody look. Ashton, you're going to build something like this. Take turns. I don't want to hear model balls hitting the floor. I want you to take turns. I want you to be careful with these, all right? We don't have many of them. We need to be careful with them. Once you make your model, then you're going to draw it in the next column like you're in art class. I want you to pretend like you're in art class, and you're going to draw this little thing you made. So mine's going to look maybe like that. I'm not too good. I might fail art class. Mine looks like kidneys. Alright, so now I'm going to color them green. Oh, it's beautiful. Now, you're not being graded on your art, but I want to see what it looks like. I want a little picture of your model. If it's 3D, I want it to look a little 3D. If it's got spikes coming off or something, I want you to try to make it look like some things are going towards you in some way. Do I expect you to be Picasso or Michelangelo or something? No. So don't take too long, but I want a model built, and I want you to draw each one. When you build the model, I will come around, or Miss Olivier, and we have to initial that you actually built it and that you show it to me. Do you understand? Okay. All right. So I'm going to give one kit for every 3 tables. So it'll be 1, 2, 3, 4, 5, 6. Because I have 6 kits here. All right. So there's one for y'all. There's one. Oh, I'm putting them in the middle. You're going to work with your group here. This one. This one. All right, so start doing the back of the page. Start filling it out, building your models. Raise your hand when you're ready for me to come sign one off. So this one goes there. Bond structure is there. All right, here's your model kit. Get started. You can do it. All right, everybody get started. Pick your phones away. Get out your lab. You can finish the front. But I have to initial the ones on the back. So work together with the 3 tables in your group. So you understand you're here. Guys, y'all understand you're working here. Guadalupe, you understand you're working behind here with Alan. You're working with you're working here. Y'all can take your chair and scoot up. You can move your chair and scoot up. Guys, y'all can move your chairs up. Y'all can sit right there and then flip the chairs. Y'all understand you're working with them, right? Right, you understand you're working with them, right? Make new friends and keep the old. One is silver, the other gold. So don't lose that. We got brand new kids. Those are chlorines. Chlorines are always green. Carbons are black. What graph? Oh, yeah. There should be one in here with your name on it. So Miss Olivia said there. Oh, you were here. You just lost it. Okay, yes. Okay, you can have it. You can have it. Thank you. You're welcome. Did you get your lab paper out of there? You can build them all and then have me come, or I can come before that, but I have to sign that you did it. Yeah, start building this.